Hi guys, welcome to another Dawn Academy video. Today we're going to be talking about integration. So we're going to start with level 1, then we're going to move to level 2, and finally level 3. We're going to talk about simple integration, which is like the basic integration. We're going to talk about u-substitution, which is level 2. And finally, we're going to get to definite integrals, which is the hardest level. But it's really not that hard. You will see. Okay, so we're going to start off with this. Oh, and we have one problem of simple, we have two problems of u, and one problem of definite, and that will wrap up our video. So let's just go through the basics. So what is integration? Well, integration is the opposite of a derivative. So let's say we have x squared. If we want to derive x squared, we're going to get 2x. If we want to go, let me put dx here. If you want to go backwards from here to here, that would be considered integration. So if we're starting out with 2x, if we want to unintegrate it, if we want to underive it, which is anti-deriving, which is integrating. See what I did there? Underive, which is antiderivative. So if they tell you to find the antiderivative, they're telling you to find the integral, which is an integral. So that's kind of our goal here. We're trying to undo the actions of the derivatives. So if you want to go back from here to here, we have to add 1 to the power. So we're going to go n plus 1, and we're going to multiply it by 1 over n plus 1. So if we want to go back, we're going to get x to the power 2, because it's n plus 1. Here the power is 1. And we're going to multiply it by half. Half times 2. So this is a 2. And this is the 2 as well. We're going to multiply it by half. And that is how we get there. So that's just the power rule. Okay, let's start off with the simple integration. So this is the format of how we integrate. We're going to have our little integral over here. This is our little integral sign. We have to end it with in terms of what. So this sign like doesn't, you're not really doing anything with it. It's just there. It's just floating there. So what we're going to do is we're going to have this as our staple and this as our staple. We're just going to be looking at this one in the middle. So, okay, let's start. So, what do we see here? Well, I see that we have a t, and a t. And this has power 3, power 5, power 5. So, I'm seeing that we can distribute this t and maybe make it into 2 fractions. Let's see. And since we haven't integrated yet, we have to keep these staples. So, I'm just going to write them down first so I don't forget them. Okay, so I'm going to go t over t to the power 3 over t to the power 5 because I don't know how to integrate it in this format and I don't want to multiply it by t to the power negative 5. So this is what I'm going to do. Minus 3t to the power 5 over t to the power 5. And hey, look at that. We can subtract them now. So once we subtract the powers, we're going to get t to the power of negative 2 minus 3 minus just 3. See? Look how simple that is now. Now, if you want to integrate this, we're going to go, let's do each one alone. So if we want to integrate this, actually, let's talk about this rule. So we would basically have the integral of t to the power of minus 2 minus the integral of 3. Basically, dt. This is how we're going to think of it. We don't have to write it in this notation though, so we're just going to integrate each one alone. So t to the power of minus 2. What did we say for the last one? We're going to add 1 to the power. So we're going to get negative 1 over, we're going to get 1 over the power plus 1. So we're going to get negative 1 times t to the power of the power plus 1. So minus 2 plus 1, which again is minus 1. So we're going to get minus t to the negative 1, which is going to be minus 1 over t. See how I did that? So we started with this, and the rule is, maybe I can write the rule up here somewhere. Okay, I'll write it over here. So the rule is n, oh no, let's not use that, x to the power n. When we integrate it, we're going to get 1 over n plus 1 times x to the power n plus 1. So let's see how we did that over here. We have minus 2. When we want to integrate it, we have to do 1 over n plus 1, which will be minus 2. Let me write minus 2 plus 1. minus 2 plus 1. Oh. Yeah, minus 2 plus... Oh, no. Minus 2 plus 1. Okay, minus 2 plus 1, which is going to be minus 1. Let me do some more steps. So we're going to get 1 over minus 1 times... So you write this as minus 2 plus 1. So we're going to get minus 1 times t to the power of minus 1, which then will be minus 1 over t. Okay, that's just the power rule. So when we integrate it over here, we're going to get minus 1 over t minus, and now we have to integrate the 3. If we do a similar rule for the 3 over here, we're going to get, so we have a minus 3 here. When we want to integrate 3, and imagine this is x to the 0, we want to multiply by, basically it's going to be 1, because 0 plus 1 is 1. So minus 3 times 1 over 1. I'm just writing it so we can understand it. Times 3x to the power of 1, which is n plus 1, which is 0 plus 1, which is 1. So basically we're going to get minus 3, oh, not 3 again, minus 3x. So it's minus 3x. And that is our final answer. But wait, we have to add plus c, because we don't know what constant there could be. So we're just always going to add plus c. And yeah. So maybe a quick recap would be good. So a quick recap is we divided this by this and this by this, and we split them apart, and we got this. After we did that, we subtracted the powers, we got minus 2. We subtracted the powers, we got 0. Oh, and sorry, don't make this mistake that I made. I didn't put a t, I put an x instead, because I was explaining in terms of x, and we're writing in terms of t. All right, so after we did that, we got this power and a 3. And then we removed this, and we removed this, and we integrated. So here's integration. This is what's happening right now. And while we're integrating, we got this using the power rule and this using the power rule, and we have to add a plus c at the end. And this is our final product. All right, moving on. U-substitution, level 2. So we need to know, before our test, we definitely need to know that, for example, our cosine is going to derive into a sine. Our sine is going to derive into a minus cosine. Our 1 over x is going to derive into an ln absolute value of x. We need to know that, what else? The rest are pretty obvious. They're power rules. We need to know that 1 over cosine squared is going to derive into tangent. Yeah, basically, those are the staples. So definitely write those down, look them up, know them by heart. So what we're seeing here is we have a cosine of x squared times x. So we kind of have two terms here. We're going to have this term, we're going to have this term. There's no quotient rule in integration or product rule. So what we're going to do is we're going to use u-substitution. So what this means is, maybe I'll solve this one and explain as I do it. So I'm going to replace the x over here with a u. A u is going to be a random u. So I'm just trying to simplify this by making it in terms of u, because I don't want x squared. I don't want all this crazy stuff. So I'm going to let u equals x squared. So why did I do this? Because I don't know how to integrate cosine times x, but I do know how to integrate f of x times f of x prime. I do know how to do this. When I'm multiplying a function by its derivative, these essentially cancel out, and I get f of x. So basically, multiplying by the derivative kind of cancels out the integration. Let me just say that one more time in case you need a bit of clarification on that. So when I have a function that I'm trying to integrate, which in my case is going to be f of x. So over here, I'm going to have my cosine of x, and I have it in terms of x. What I'm going to try to do is multiply the other term, get this function to be multiplied by its derivative, which in my case is going to be this x over here. And essentially, when I do multiply the function by its derivative, these are all going to cancel out. The derivative will cancel, the dx will cancel, and the integration sign will cancel, and I will be left with my integrated answer. So let's go through that. It'll make more sense as we do it. So my u here is what I'm trying to find the derivative of. So if my u is x squared, du, which is u prime, is going to be 2x. And hey, look at that. I'm basically multiplying by 2x, just not exactly. So what I want to do, oh, and we have to add d of x at the end. So what I'm going to do here is I'm going to see how can I get x dx and what do I need to multiply it by? So if I want to get x dx, I'm going to have to get du over 2 equals x dx. So I need to multiply this situation by half so I can get half and 2, so I can get 2x, which is the derivative. So let's apply this. I'm going to multiply by half out here. I'm going to have cosine x squared times 2x dx. Oh, 2x dx, yeah. So I want this. This is what I want to have in my equation. And look at that. After I multiplied by 2 and canceled it out with this half, we can't just multiply by 2 because that'll be changing the equation. We can't just multiply an equation by 2. We don't have an equation to multiply by both sides. We only have an expression. So what's going to happen is that we're going to multiply by 2 here, and we're going to cancel that 2 by multiplying by half out here. Now, after we do this, I said that this will cancel, and this will cancel since I'm multiplying by the derivative. So after those cancel, we're going to wind up with our integral, which is going to be half times, oh, let's write it, sorry. Let's write it in u first before we cancel all this stuff out, just so I can show you how it's applied. We're going to have half the integral of cosine u. Remember, x squared is our u. So we're changing this whole x squared and we're putting u in its place. We're changing this whole 2x dx and we're giving it to du. So I'm just substituting here. I'm substituting for u and I'm substituting for du. So x squared is going to substitute into u times this is going to be du times du. Okay, now we can do the canceling. This is going to cancel. This is going to cancel. Yeah. So what's going to happen now is we're going to have our integral, which is going to be half. And now we actually need to integrate this. So integrating cosine of u, we're going to have cosine integrates into sine, whatever, of x. So cosine here is going to integrate into sine of u. So 1/2 sine u plus c. Remember from here, we always need to include our plus c. And after we do this, after we get to our final integral, we're going to replace u with what we started our u with, which is x squared. X squared plus c. And boom, that is your integral. Let's do a little recap again. So we started out with this, and we found what our u is, and we found what our u prime is, and we wrote them down over here, and we took the derivative because u prime is basically du. So after we did that, we allocated this to be u, and we allocated this to be du, and we replaced them with u and du to make things simpler. And after we did that, we found out that to have our complete integral, we need to multiply this by half and this by 2. And we need to multiply by half to cancel out the 2. So we multiplied by half and 2, and then we were able to replace this as du. After doing that, we were able to cancel out this and this, the integral sign and the du, and we were left with, and when we integrated the cosine, it integrates into sine. So we were left with half sine u. Obviously, we have to add our plus c. So we added our plus c. And then at the end, we replaced our u with our starting substitution. And boom, is our integral. Now let's do this one a little bit faster. Try to pause the video and solve it on your own. See if you can do it. Okay, now I'm gonna solve it. So, okay, I'm seeing my function here. My function is gonna be power of 10, and my u is probably gonna be this, I'm guessing, because it's longer, it's more complicated. So let's start out with that. Let's start out with setting my u to let u equals x cubed plus 2. Now, my u prime, which is my du, is going to be 3x squared. This goes into 0. So, now, let's substitute. So, we're going to have my u is going to be u to the power of 10 times, how am I going to get, oh, look at that. It's already set for us. We don't even need to multiply it by 3. We already have our perfect du. So u to the power of 10 times du, which is this. Oops, sorry, I forgot the dx here. This. Look, they're the same. We didn't even have to do anything. How beautiful. Okay. Now we actually need to do the deriving part. So here, look, it's familiar. It's u to the power of 10. What we're going to do is we're going to do 1 over n plus 1 times u to the power n plus 1, which is, this is our deriving. So I'm going to put an equal sign, and I'm going to cancel out these. But don't cancel them out on your paper. So we're going to have 1 over 11 u to the power 11 plus c. And hey, look at that. We're going to replace our u again with x3 power of 3 plus 2 over 11 plus c. And boom, that's our integral. Quick recap again. Did you get that right? What we did was we found our u, which is this. We put it in here, then we found our du, and we said, hey, look at that. We have the du already made for us. They're so nice. So now we replace our u, and we replaced our du, and then we integrated this, and we added our c, of course. We added 1 to the power, 1 over the power as well. 1 over 1 plus the power. And we got 1 over 11, u to the power 11. And we replace our u at the end with our starting u. And of course, our c. Super nice, super beautiful. Okay, level 3. Congratulations, if you made it to this point of the video, you're acing your test. Okay, so definite integrals. What does that even mean? Well, a definite integral is just integral of a specific number minus the integral of another specific number, and that is your definite integral. So let's say we're starting out with this this expression, and they tell us, okay, like first, we're going to need to find the integral, which is right here. Once we find the integral, let me write these steps down. So, 1, find integral. Okay, sounds simple. We know how to do that. Use our u-substitution. Depends on the expression. If it's simple, we can use simple integration. If it's complicated, we can use our u-substitution. So we're basically using what we learned. Using u-sub or simple. Number 2, you have to find integral in terms of specific given bounds. So what does that mean? So here they're going to put you 2 little numbers on your integral sign. This is going to be the upper bound. This is going to be the lower bound. Always remember, you're subtracting top from bottom. So you're doing whatever integral of b is minus the integral of a, which is shown here. F of b minus f of a. So find the integral in terms of the specific bounds, and then difference of f of upper minus the difference of f of upper and f of lower. Upper and lower, I mean bounds. So upper minus lower, upper minus lower, upper minus lower. Don't forget, upper minus lower, not lower minus upper. Okay, that better stick in your head. Okay, so that's it. That's your answer. So here you're going to get a number. So you're going to be expect a number. answer. So we're not getting an equation like we were getting with the integration. Like over here, our answer was this, because it's indefinite. So we don't know what numbers we're using. Here, we're actually going to get a number. Okay, that's it. You're basically using your integrals and just solving stuff with them. All right, so given upper bound is 3, lower bound is 1. Integrate this, and you substitute the numbers in, and do it. Try this on your own. Pause the video, see if you can do it. Okay, so I'm going to do it now. And let's just say we're going to get a certain f of x. And then we're going to need to do f of 3 minus f of 1. Because we're doing upper minus lower, upper minus lower. Okay. Wow, I sound a little bit goofy. Okay, so we're going to integrate this first. 3x squared minus 2x plus 1. If you can do the other problems, you can definitely integrate this. Super simple. So what do we see here? We don't have any u-substitution. We just have simple additions and subtractions. So we're going to integrate this into, we're going to use the power rule. 2, okay, so 3 times, what's 2 plus 1? 3. 1 over 3. What's 2 plus 1 again? 3. Power 3, 1 over the same number as the power. Then we're going to integrate this one. 2, what's x to the power, we're going to start with 2, times, what's x to the power of, x is to the power of 1. So we need to add 1 to the 1, which is 2. So we have half, and then x to the power of 2 again, plus 1. 1 integrates into x, and plus c. So now I just have to work out these simple, these cancel, x to the power 3 minus, these cancel, x to the power 2 plus x plus c. So this is our indefinite. Okay. Oops. Indefinite. With a c. But now, when we want to put the specific values in, so let's say this is f of x. Capital F is for the integral. Okay. Now, we're going to do, we finished step 1, which is just finding the integral. And we use simple. Now, we have to find the integral in terms of specific given bounds. So our specific given bounds were 3 and 1. So now, I'm going to find f of 3 minus f of 1. Yep, sounds about right. So, the first one is going to be 3 to the power of 3 minus 3 to the power of 2 plus 3. That's going to be our first one. This is f of 3 minus f of 1, which is going to be 1 to the power of 3, minus 1 to the power of 2 plus 1. Okay, let's see now. 3 cubed is 27 minus 9 plus 3 minus the whole f of 1, which is going to be 1 minus 1, which is 0, plus 1, which is 1. So 27 minus 9 is 18. 18 plus 3 is 21. 21 minus 1, we're going to get 20. This is the solution to our problem. Oh, that wasn't a good square. There we go. Okay, that's it. So let me do another recap. So what we did here was we found the integral. I kind of mashed these two together. And we expected a number for an answer, which we got 20. Did you guys get 20? Let me know in the comments. Okay. So first, we found our integral. And we got this as our indefinite integral of this. And then we had to use our bounds, and we had to substitute the x for bounds. And we had 3 and 1, which is upper minus lower. And over here we got 21. Over here we got minus 1. And at the end we got our answer, which was 20. Okay guys, that's all I have for you today. If you like this video, do let me know. And if you have any questions, let me know in the comments. Bye.